In this video, we're going to look at a way to use linear regression with data that is non-linear. We'll first answer the question using Excel, and then we'll answer the question again using a calculator. We'll start by copying the data into Excel. The governing equation is altitude is equal to a half AT squared. So we need a row for t squared. So let's move this row down one. We'll calculate the first cell, so that is equal to, and then we'll just copy that like so. It's always a good idea to graph data to get a visual representation of the relationship. So let's mark that, say insert, scatter graph, and I'm just going to put the points on. And this is a graph of altitude versus time squared. For the Pearson correlation coefficient, we use the function equals Pearson. We give the first array, comma, and then the second array. Close brackets. We've got a value of 989, which is very close to 1, so we've got good correlation. So let's put that answer into Babbage. To find the gradient, we use the function slope. First of all, we give the known y's, comma, then we give the known x's, close bracket, equals. So we've got a gradient of 0.95. To find the y-intercept, we use the function intercept. And as before, we give the y's, the known y's, followed by the known x's. And that's given us the intercept. So we've now got an equation for the line, which is 0.95x minus 79.8. So let's put that answer into Babbage. If we look at the graph, we can see we've got meters on the y-axis and seconds squared on the x-axis. The gradient is given by the change in y divided by the change in x, so the units of the gradient are meters divided by seconds squared. So we can put that into Babbage, meters per second squared, and that's correct. And then finally find the acceleration. We can see that the altitude is equal to a half AT squared. The gradient is the half A, which means that the acceleration is equal to twice the gradient. So the gradient is 0.95, so the acceleration is equal to 2 times the gradient, which is 1.9. So the acceleration is 1.9. And if I say, am I right now? It says no units, which means that the number is correct, but I haven't specified what the units are. So the units are in meters per second squared. Am I right now? Yes, I am. Now I'd like to repeat the process using a calculator. We move on to statistics, and we've got two variables, and now we'll put the data in. We can use the square button here to square the data as we put it in. So we've got 10 squared xe and now we go to the y column and we put in the data 100, Next we press OK So we can either just click on the 2var results, in which case we get a table of the data, or we can click on reg results for regression results, and we'll choose linear regression, and there we've got the values that we calculated. So we've got r is equal to 0.989. We've got the gradient is equal to 0.95, which is 0.95 here. And we've got the intercept is equal to minus 79.84, which is minus 79.84. The units of the gradient obviously haven't changed. And then double 0.95 is the 1.9 that we've got there. And that's one way to do linear regression when you've got non-linear data.